Ladies and gentlemen, my name is Yong, and I'm from XMight Smart Energy. So we are talking about the power issue about the data center, and our solution, Dynamic Power Orchestrator, or DPO. So we face two major problems. First, stranded capacity. AI rack only run around 60% to 70% percentage capacity just to handle power spikes. And second, a major risk to the grid stability. After a power fall, the power grid is fragile, it's very weak, and the need to large power user like the data center to resume their full load in under 1 second to avoid the wide blackout. And the grid operator like ERCA now making this mandatory requirement for the interconnection. Means if you cannot meet this requirement, you cannot connect your new data center into the power grid. So it will delay your AI data center deploy schedule. And this is the coupled. These are the million-second scale power spike. The massive current overshot, and the peak current can jump from the 7 ampere to the 25 ampere just a few AC cycles. At the rack level, this creates chaos. Pure software is too slow to react. So we need to have a hardware level solution to manage the power at the speed of electricity. So our solution is Dynamic Power Orchestrator, or DPO, a system with the brain and the reflexes. The DPO engine is the central brain, and it reads label schedule and the workload to predict the power, the rack power load, and then send a high-level prediction instruction to the DPO gateway. At the rack level, the DPO gateway act as a reflex. This is our simple PIM comparable device to the power monitor interface. So it uses a sub-millisecond leading indicators from the GPU, hosts the CUDA kernel submission and the NCCL event as a leading indicator to spike or offset around 100 to 300 milliseconds earlier. So we use this indicator to predict the coming future GPU power spike. This two-stage prediction is our key. The engine provides the strategy, and the gateway execution with sub-3 millisecond speed, commanding the BBU to abstract the power spike perfectly. For the grid compliance, like a PFAPR, this process as the orchestration enables the perfect sub-second power handover. So this is our result. And the smooth blue line is the rack AC side power, mentioned by our DPO. And the red line is without. So we can see that the DPO use the two BBU to absorb the peak and fill in the value, creating the near flat and the predictable power draw. So we do this while the active keeping the BBU in a healthy and a state of charge around 60% to 65% to ensure the long battery life. And this is our result. And what's the mean in the numbers? 3 key results. First is the 25 to 35% AC input current reduction in the peak to average ratio. So if we can make the AC input current stable, so we can unlock the 25 to 30% computer capacity, and we achieve the grid compliance in the less than half second. So we can turn the non-qualified rake into a reliable grid citizen. And so this is our outcome. Thank you for your listening.